Hello again everybody, and welcome to another edition of the Brommer's Blog video tutorials. This week we're going to take a quick look at the use of planes, i.e. ground and power planes within a DesignSpark PCB design. So firstly, we've got a simple digital circuit here that we're going to be using for the example. But first I want to talk a little bit about layers and the reason for them. So I've just got a slight little diagram here to look at. So when you think about PCBs, obviously on one side you have components, possibly you have components on both sides if they're surface mount. And what we saw in the industry as technology increased, the level of complexity or the density of designs increased, that it felt it was necessary there to include extra layers within a board. And this was done for a number of reasons. One, it could have been to reduce the number of traces. When we think about ICs on a board, each of those need a power and a ground. You know, rather than having to run traces, PCB traces across the whole, or tracks across the whole PCB, we could see here in a 4-layer board, and it is literally like a sandwich. We've got the top copper layer, a ground layer, a VCC and a bottom copper. You could actually just put using wires to punch down into the ground, into the VCC to take power locally from the actual ground or power planes. What this also offered in terms of benefits was having a large area of sort of copper, like for a ground plane, obviously can help with things like noise, EMC considerations within a design. Also, you know, good grounding is always a good rule of thumb, you know, for all you know, electronic circuits, especially digital ones. So this was just maybe sort of a couple of the benefits, especially in high-speed designs. These kind of usage of planes can be useful too. So what we're going to look at today is how we take what we see as like a simple two-sided board within DesignSpark PCB, and we're going to introduce extra layers which actually physically exist sandwiched within a circuit board. So again, when we come to this, we're going to take a simple design here, what we've got now here, the digital circuit with a connector, 2 integrated circuits and a plug. We're going to do a quick translation to PCB, and we're going to look to introduce board layers for the VCC and ground. So very quickly we're going to come to the translate to PCB, which I covered in the last video. I'll just rush through to where I want to be. So here we can see on this screen that we're defining the layers. So the defaults come off this design as a 2-layer board. What we want to now do is to increase this to 4 layers. And now we can see just here that these have become active layers 2 and 3, i.e. inside the board. At this point here, I can set these, and these are nets that are available from within the schematic. I'll set layer 2 to VCC, and I'll set layer 3 to ground. You can see here, actually now in the options with the DesignSpark PCB, that it has the capability to go up to 14 layers. So you can imagine a 14-layer sandwich PCB. You would see this kind of technology on maybe on something like, maybe possibly even like the latest iPhone 4s, whether you have real high density designs. So we've selected here a 4-layer board to introduce these 2 extra layers. So we'll just move quickly through here. I'll just create the PCB very, very quickly, the example. Okay, we'll just read these very quickly. Okay, so just zoom in on this. So basically what we have very quickly, very crudely, is a basic PCB layout. So here you can see a number of the colours, for the red for the top copper and blue for underneath. Now using the interaction bar by pressing F9, which I'd already done, you can actually go to the layers. Click on that. So we can see included in this design now a top documentation, which we can turn off, silk screen, bottom silk screen and bottom documentation. So what we've got here is top copper. We turn that layer off, we can see, as I said before, that's the red layer. What I can also see by turning that off is the bottom copper is indeed blue. Now, because of what we did with the ground plane, introducing the 2 new layers and specifying, we now have a VCC plane and a ground plane. Now you won't see this now here just by turning it on and off, because it is going to be a complete sheet of copper, if you like. or a layer. What we can do is go to View, Power Plane, to Show, and then we have the options to look at either the VCC or the ground plane. So by looking at the VCC plane, what we have there, the whole screen goes green. That was just a layer that was set up by default for layer 2, but you can change this. Is that we see here, the point of interest, here, we just move up a little bit. Here we can see a part there that's been isolated completely from the ground layer. But this pin here is just something like the ground layer, but from the VCC layer. Here we can see this pin is actually the VCC pin for the device. And we can see here from the spokes that are going through to that layer, and we've got like thermal relief there, is where the connection is made to the ground plane. Now if we sort of go back to what we said about reducing the number of traces, if we had not had that ground layer, we may have possibly there had to do extra tracing down to, I think this is the VCC pin here, our ground, and it would have been extra work. So if I just highlight this net, which we can see as VCC, and we highlight that, what we can see here is a number of these pins have now turned blue. Here, here, and here. Now what the interesting thing you can see there is that each of these pins, you cannot see any connection or traces coming from them. All you see is that they are connected to the plane, which means they've been connected straight down into the board. So straight away there you can see that. If we then look to highlight the power plane for the ground plane, similarly, what we will see is pins here. Again, you can see where the physical connection is made to the actual ground plane. So again, if we highlight that net, we now see excuse me, the other pins in the device where the ground connections are for those integrated circuits there, for the plug, and ultimately the D-type connector. And you can see there they're all connected to the ground plane. So just to recap what we've actually done there, we've shown that by using the ground plane or the VCC plane, we've been able to provide layers within the board, a complete sheet, or if you like, of the copper within the board sandwiched, and be able to connect straight down into that board just simply by using vias or punching through down, not using vias but drilling down through that board and being able to tag on to those layers, which has allowed us to reduce the number of traces that we actually physically needed on the board, PCB tracked. Also potentially has given us some advantages regarding grounding, EMC issues that we want, maybe have to have some, protection against, and all in all, using the translate to PCB function which you saw within the wizard, which makes it a little bit easier, you can automatically there insert new layers and assign them to whichever nets you see fit. In the case of today's example, we used the VCC and the ground nets to do that. So I hope you found this of interest this week, and certainly you will find plenty of information in the help files by pressing F1 in DesignSpark PCB on how to do this. But thank you very much.